Hi everyone, welcome to this tutorial on using MongoDB with Entity Framework Core in C#. I'm Beau Carnes and I'll be teaching this course. I'll start by giving you a brief introduction to MongoDB and an introduction to Microsoft's Entity Framework Core. Next, I'll cover how to use the MongoDB EF Core provider. After going through technical details with some basic examples, we'll create a full project with MongoDB and Entity Framework Core so you can see how everything works together. The project will use MongoDB Atlas sample data to create a restaurant reservation system. MongoDB is a popular NoSQL database designed to handle large volumes of data and provide high performance, scalability, and flexibility. Unlike traditional relational databases, MongoDB stores data in flexible JSON-like documents. This document-oriented approach allows for the storage of complex data structures in a more natural and intuitive way. In MongoDB, data is stored in collections, which are similar to tables in relational databases, but without a fixed schema. This means you can have documents with different structures in the same collection. This flexibility is one of the key advantages of using MongoDB, especially when dealing with unstructured or semi-structured data. Let's take a look at an example of a MongoDB document. Imagine we have a collection called Users that stores information about users in an application. Here's what a typical document might look like. In this document, we have various fields such as name, email, age, and address. The address field itself is an embedded document containing multiple subfields like street, city, state, and zip. Additionally, the hobbies field is an array of strings. While this looks like JSON, MongoDB stores data in a binary format called BSON, or binary JSON. BSON extends the JSON model to provide additional data types, such as integers, floats, dates, and binary data. This binary format is optimized for performance and flexibility, allowing MongoDB to efficiently store and retrieve data. Another important feature of MongoDB is its ability to scale horizontally. This means you can distribute your data across multiple servers, making it easier to manage large data sets and ensure high availability. MongoDB also supports rich queries, indexing, and aggregation, making it a powerful tool for a wide range of applications. For example, you can perform a query to find all users who live in a specific city. MongoDB is widely used in various industries, from e-commerce and content management to real-time analytics and Internet of Things applications. Its flexibility and scalability make it an excellent choice for modern applications that need to handle diverse and dynamic data. Now that we have a basic understanding of what MongoDB is and why it's popular, let's move on to another essential tool in our tech stack, Microsoft's Entity Framework Core. Entity Framework Core, often abbreviated as EF Core, is a modern object database mapper for .NET. It allows developers to work with a database using .NET objects, eliminating the need for most of the data access code that developers usually need to write. EF Core is a lightweight, extensible, and cross-platform version of the popular Entity Framework data access technology. It supports a variety of database engines, including SQL Server, SQLite, and MongoDB. One of the main benefits of using EF Core is that it enables developers to work with data in a more intuitive and object-oriented way. Instead of writing raw SQL queries, you can interact with your database using LINQ, the language integrated query, and strongly typed classes. Let's take a look at a basic example. Imagine we have a product class. Here it is pretty simple with just 3 fields. Using EF Core, you can create a context class that represents a session with the database and includes a DB set for each entity type you want to query or save. This code defines a class named AppDBContext that inherits from Entity Framework Core's DBContext class. This class is used to interact with the database. Inside this class, there's a dbSetProduct property called products, which represents a collection of product entities and corresponds to a table named products in the database. The onConfiguring method is overridden to configure the database connection, specifying that SQL Server is the database provider. But you can also use other databases besides SQL Server. The method uses an option builder to set up the connection with a placeholder for the actual SQL Server connection string. This connection string obviously should be replaced with the real one containing the necessary details to connect to the database. When you create an instance of appdb context in the application, it uses this configuration to perform operations like querying or saving product entities in the products table. With this setup, you can perform CRUD, create, read, update, delete operations using EFCore. For example, to add a new product to the database, you can use this code. This code demonstrates how to add a new product to the database using Entity Framework Core. An instance of appdb context is created, and within this context, a new product object with the name laptop and price $999.99 is instantiated. This new product is then added to the products collection managed by the appdb context. Finally, the save changes method is called to save the changes to the database, effectively inserting the new product into the products table. To query products, you can use link. This code also demonstrates how to query the database using Entity Framework Core. An instance of appdb context is created, and within this context, a query is made to retrieve all products with a price greater than 500. The results are stored in a list called products. Then a loop iterates through each product in the list, printing the name and price of each product to the console. EFCore takes care of translating these link queries into the appropriate SQL commands for your database. This makes data access simpler and more maintainable. EFCore also supports advanced features like change tracking, lazy loading, and migrations, which help you manage database schema changes over time. In summary, EFCore is a powerful ORM that simplifies data access in .NET applications by allowing you to work with your data using .NET objects and link. Its support for multiple database engines and its extensibility make it a versatile choice for a wide range of applications. Next, we'll see how the MongoDB EFCore provider bridges the gap between MongoDB and EFCore, allowing us to use the familiar EFCore patterns with a MongoDB database. The MongoDB Entity Framework Core provider is a tool that enables developers to use MongoDB with Entity Framework Core, combining the flexibility of MongoDB with the familiar API and design patterns of EFCore. This provider allows you to work with MongoDB using the same code-first and link query methodologies that you would use with relational databases, streamlining development and reducing the learning curve for those already familiar with EFCore. The MongoDB EFCore provider bridges the gap between MongoDB and EFCore by supporting basic CRUD operations, link queries, and embedded documents, among other features. Here are some key capabilities. Code-first workflows. You can define your data models in C# and use EFCore to generate the MongoDB schema rather than starting with the database schema and generating code from it. This is particularly useful for developers who prefer to manage their database structure through code. CRUD operations. The provider supports basic create, read, update, and delete operations. For example, you can add a new record to the database using the same code we saw earlier. Link query support. You can use link to perform queries against MongoDB, allowing you to leverage your existing knowledge of C# and .NET to interact with the database. Change tracking. EFCore's change tracking capabilities are supported, enabling automatic detection and saving of changes made to your data entities. Embedded documents. The provider supports embedded documents, allowing you to store related data within a single document, which is a common pattern in MongoDB. Class mapping and serialization. Your C# classes are mapped to MongoDB collections with support for various data types and serialization settings to ensure that data is stored correctly. Now we'll go over a quick example on how to use the MongoDB EF Core provider. And later, we'll create a full project in Visual Studio Code so you can see everything in context. In this section, we'll explore how to define data models and perform CRUD operations using the MongoDB Entity Framework Core provider with MongoDB Atlas. This integration allows you to leverage the flexibility of MongoDB with the familiar patterns of EF Core. To get started, you need to add the necessary NuGet packages to your project. These packages allow your application to interact with MongoDB through EF Core using the same context and entity definitions you would use with a relational database. Before you can perform CRUD operations, you need to set up a MongoDB Atlas cluster and connect your application to it. Here are the steps. Note that we'll be going over these in detail when we create the project soon. First, sign up for a MongoDB Atlas account. You can sign up for a free one at their website. Next, create a new cluster. MongoDB Atlas provides a free tier that is perfect for development and small-scale applications. Then you get a connection string. You can obtain your connection string from the MongoDB Atlas dashboard. It will look something like this. So after getting set up on MongoDB Atlas, time for the code. You need to define a class using a model for your entity. For this example, we'll create a customer class. This customer class represents the structure of the documents stored in the MongoDB collection. To begin using Entity Framework Core, create a context class that derives from DB context. The DB context derived class instance represents a database session and is used to query and save instances of your entities. The DB context class exposes DB set properties that specify the entities you can interact with while using that context. This example creates an instance of a DB context derived class and specifies the customer object as a DB set property. With the MongoDB EF provider, you can use a code-first workflow. This means you define your classes first, and EF Core will handle the creation and management of the underlying MongoDB schema. This is particularly useful for MongoDB, which does not enforce a schema, allowing for flexible and dynamic data structures. Once we've created a DB context class, we need to construct a DB context options builder object and call its useMongoDB method. This method takes two parameters, a Mongo client instance and the name of the database that stores the collections you are working with. The useMongoDB method returns a DB context options object. Pass the options property of this object to the constructor for your DB context class. Now let's see how to code the CRUD operations. We'll just focus on each operation individually. To create a new document in MongoDB, you use the add method on the DB set and call save changes. Here's an example of creating a new customer. This code creates a new customer instance and adds it to the customer's collection. The save changes method saves the new customer to the MongoDB database. To read documents from the MongoDB collection, you can use link queries on the DB set. This is an example of retrieving all customers. This code retrieves all customers from the customer's collection and prints their details. To update an existing document, you retrieve the document, modify its properties, and call save changes. Here's an example of updating a customer's order. This code finds the customer named Beau Carnes and updates their order to smartphone. To delete a document, you retrieve the document, remove it from the DB set, and call save changes. Here's an example of deleting a customer. This code finds the customer named Beau Carnes and deletes them from the customer's collection. EF Core's change tracking capabilities are fully supported, enabling efficient updates to documents. When you modify an entity and call save changes, EF Core will generate the necessary MongoDB commands to update only the changed fields. By using the MongoDB EF provider, you can seamlessly integrate MongoDB's flexible document model with EF Core's robust ORM capabilities, providing a powerful toolset for .NET developers to build modern applications. Now let's put everything together and develop a full restaurant reservation system from scratch. So let's see how to use MongoDB with EF Core in a real-world project. Well, this is kind of like a demo project. We're going to make a restaurant reservation system, and we are going to use some sample restaurant data that MongoDB provides. So before we create our project, let's get our database set up. So this is free. We just have to sign in or sign up. Now, if you're signing up for the first time, it may make you set up a project as part of the sign up process, or we can just go to new project. And I'm going to call it RestRes for restaurant reservations. And then we'll just go through this process here of signing up. And then I just need to create a cluster, and I'm going to create a free cluster. And I'll just set all this, the rest of this to default. You can also change the region to get a region that's closer to where you live, and I will do create deployment. And we have to make sure our IP address is added, and so it's going to automatically add your local IP address, but if you're switching systems, you may have to make sure your IP address is whitelisted so you can connect from that IP address. And then we need a database user. And then I'll just create the database user, and then we can choose a connection method. Now we're going to be coming back to this, but we're going to need this MongoDB URI, but I'm going to copy that later. So I'll just click done for now. And I'm going to click add data, and then the load sample data. So this is great for any projects that you're working on, and when you're learning, you don't need to find your own data somewhere. You can start with a sample data set, and that makes learning how to do things with MongoDB a lot easier. So we're just going to start with this sample data, and so when we create the project, there's already going to be a lot of data to work with. We're specifically going to be using their restaurant database, but they have a lot of other data you can work with. And this actually has a bunch of, so this has 8 sample data sets. So you can see them all here. Here's all the different sample data sets you can work with. We will be using the sample restaurants data set, but it's going to load all of them into the database. So our database is still being set up in the background right now. So let's get our project set up. Now there's a few different ways we can create our project. Some people may be using Visual Studio. Some people may be using Visual Studio Code. Now, since I'm running on Mac OS, Visual Studio, they're deprecating Visual Studio on Mac OS, and it's going to be mainly focused on Windows. So I'll be using Visual Studio Code. Now, Visual Studio works more out of the box for C# projects and ASP.NET projects, but Visual Studio Code also works. You just have to install the right extensions. So if we go to the extensions, you're going to make sure to install the C# dev kit. And when you install the C# dev kit, it's also going to install some other things like the C# support and some other things. And once you get this installed, it's going to take a while to install, but it's helpful to go through this walkthrough. It should appear right here on your welcome screen. And then it's going to have a few things you have to do, like connect your account, set up your environment, open your folder. That's to open if you already have a folder you're going to use, but we're going to actually create a new .NET project. So now that we have the C# dev kit installed, we can create our new project. So I can either click this button, or I can go to the command palette. You can use the shortcut key or go to View Command Palette. And then we just have to search for .NET New Project. It's already showing at the top for me because I've recently used that. So I'll select New Project, And then it's going to give us some different templates we can use. So for this example, we're going to use the .NET Core Web App Model View Controller template. And then we can name the new project. I'm going to name it so Restaurant Reservation, and then press Escape. And then I am going to choose the default directory. I already opened this Visual Studio Code in a directory, so it's going to save in that directory. And then I will create the project. Okay, so now you can see it's creating all these project files here. Now, this is one good thing about ASP.NET Core. It's a very flexible web framework, and it allows to scaffold out different types of web applications that have slight differences in terms of their UI and structure. Like I said, we're using the MVC project, and this is going to make use of static files and controllers. But you could also do other things like React, but MVC with the .chtml files, which we'll see later, are the most commonly used. Now, if you're not on VS Code, you'll be using Visual Studio, and there's some different ways that you need to create your project. Or you can use the command line interface. So if you go to the article that I have linked to in the description, you can see the commands if you want to use the .NET CLI to create the project. And now that we have this project created, we want to go ahead and add the required NuGet packages. Depending on whether you're on Visual Studio or Visual Studio Code, the way to use the package manager is a little different. But let's see how to do it on Visual Studio Code. So we'll just go to View, Command Palette, or you can use the shortcut. And then we're going to go to NuGet, Add NuGet Package. You can type it in, but I've already recently used this, so it's at the top. And then we can just search for the package we need. So we actually just have to add one NuGet package, and then it has all the rest of them as dependencies that are already installed automatically. So we'll do MongoDB.entity, and if I just search for that, it should come up, see the MongoDB Entity Framework Core. So I'm just going to select that package, and I will install the latest package version, and then that's all there is to it. So it's going to automatically install the Microsoft EF Core package and the MongoDB C# driver as a dependency. Okay, now we can create the models. Before we can start implementing the new packages we just added, we need to create the models that represent the entities we want in our restaurant reservation system that will of course be stored in MongoDB Atlas as documents. So we're going to create models for the restaurant, reservation, and MongoDB settings. So let's start with the restaurant model. This is going to represent the restaurants that are available to be reserved in our system. So let's go into the models directory here, and I'll just do new file, and then I'm going to do restaurant.cs. Now, if you're using Visual Studio, there'll be you can just go to new model and then type in the name, but for Visual Studio Code, we have to make a new file just like that. So I'm just going to paste in some code here, and you can see we are going to be using MongoDB.entity Framework Core, like we just installed, and these are just the fields that will be in our database for each object: the ID, name, cuisine, and borough. Now you can see the collection attribute right here before the class. This tells the application what collection inside the database we are using. This allows us to have different names or capitalization between our class and our collection should we want to. Now, so we can kind of understand this fully, let's actually go and look at the collection on our database. So our data set was successfully loaded. We did that earlier. So let's browse the collection. We're actually going to look at the data in here. So we can see all the different sample databases, but we're only going to be using the sample restaurants database, specifically this restaurants collection. So we can see all the different items, and you can see each item in this collection is going to have an address, a borough, cuisine, grades, name, restaurant ID. We're simplifying this, and we're only going to be using the borough, the cuisine, and the name. So if we go back here, that's why we have the cuisine, borough, name, and then the object ID, because every object in MongoDB has its own object ID. If you're designing something from scratch and you don't already have some sample data, you can basically put in anything you want here, but I just took some fields from the database we already have. So let me save that, and we also need to make a reservation class to represent any reservations we have in our system. So I'm going to go to a new file. Again, you go to new class if you're on Visual Studio, and this will be called reservation.cs. And I'm just going to paste in some code again here. And so we're going to have the ID, and then we're going to connect it to our restaurant by having a field for the restaurant ID that corresponds to our restaurant ID. And we're going to bring in the restaurant name. And the new thing we're going to have is a date. And the date is going to include the date and the time of the reservation. That's why we are using a date time piece of data. So we're going to just create one more called MongoDB settings.cs. Now, this won't be a document in our database, but we need a model class to store our MongoDB related settings so they can be used across our application. So I'm just going to paste in code again here. And we can see we just have two. We have the Atlas URI. This is what we saw when we were setting up MongoDB Atlas earlier, and we're going to have to bring in that information over here later. And then we have our database name, which in this case is restaurants. Now we'll be setting this data again later, like I said. So now we're about to set up EF Core, Entity Framework Core. This is the exciting part. We're going to start to implement EF Core and take advantage of the new MongoDB provider. If you're used to working with EF Core already, some of this will be familiar to you. So let's create a folder called services. Now this part can actually be anywhere, but we're going to put it in the services folder. And then I'm going to create a file called Reservation DB context. So if you're used to EF Core, this will look familiar. This class extends the DB context, and we create DB set properties that store the models that will be present in the database. And basically, whenever you're using EF Core, you're going to have to do this part. We also are going to override the onModel creating method. You may notice that unlike when using SQL Server, we don't call the toTable. We could call the toCollection instead, but this isn't required here as we specify the collection using attributes on the classes, which I already showed you when we created the class. And just go over this a little more in detail, we first have imports, and we're going to import the models that we created that are going to be used in here. Then we have the namespace that is going to define the namespace for the class, grouping it with other related classes and avoiding naming conflicts. Then we have the class definition, and this impairs from DB context, making it a context class for EF Core. It will manage entity sets and coordinate database operations. Then we have the DB set properties. You always need these in EF Core, and this first one just represents the restaurants table in the database. EF Core will use this to perform CRUD operations on the restaurants entities, and same for the reservations. Then we have this constructor here. This accepts DB context options and passes it to the base DB context constructor. This allows EF Core to configure the context, specifying the database provider and the connection string. That's basically the other model we created. And then finally,
we are going to overwrite the onModel creating method. This method is used to customize the model building process. In this case, it's calling the base method and then registering the restaurant and reservation entities with the model builder. This step is important for setting up the model configurations such as relationships, constraints, and mappings. So we can see right here we're not calling the toTable method. That's what we would have to do if we were using SQL Server. We could call the toCollection instead, but this isn't required here as we specify the collection using attributes on the classes. This is where we specify the collection right here. So there's a few different places that you can specify the collection. Let's just save all these and get these closed. So earlier we created the MongoDB settings model. Now we need to add the values that the properties map to in our app settings. So if I go over here to appsettings.json, we can add these new properties here, and this obviously has to be updated, so we need to get the correct URI. So let's go back over here, go to database, connect, and then I can just copy this URI right from here, and now I just paste this in, and then we'll just have to update our password. And then we're going to add it to the settings.development.json as well. And I'll make sure to change this or delete this before it goes live so I don't have to blur out this URI in the video. So now that we've configured our models and DB context, it's time to add them to our program.cs file. So go to program.cs and we can see the file here. So after this line, the builder.services.add controllers with view. So we start with a configuration where we have this line that's going to retrieve the MongoDB settings section from the application's configuration file. And then here is going to map the retrieved section to an instance of the MongoDB settings class. The MongoDB settings class should contain properties that match the configuration file, the Atlas URI, and the database name. And as we know, the MongoDB settings class contains the properties that match the configuration file, the Atlas URI, and the database name. This line registers the MongoDB settings configuration instance with the dependency injection container. It allows other services to access these through dependency injection. Then we have this line, which registers the restaurant reservation DB request with the DI container. It makes the DB context available for dependency injection throughout the application. And then we have the following section, which configures the DB context to use the MongoDB provider. The MongoDB method is passed the Atlas URI and the database name from the MongoDB settings instance, and if it's null, an empty string will be used instead. And now, since I'm using all these things, you can see the red squiggly lines, we're going to have to add some using statements to import the appropriate things, our models that we created, the services, and then, of course, entity framework core. Okay, so I can save that. I saved all the other files. And now we're going to create the services. It's time to create the services we can use to talk to the database via the restaurant booking DB context we created. So for each service, we'll create an interface and a class that implements it. The first interface and service we'll implement is for carrying out the CRUD operations on the restaurants collection. This is known as the repository pattern. You may see people interact with the DB context directly, but most people use this pattern, which is why we're going to do it in this tutorial. So we already created the services directory, and now I'm going to create a new file. This is going to be the iRestaurant service.cs. This is going to be an interface. That's why it starts with the letter I. So I'll just paste in this code. We have the import, and then we have the namespace to group it with other related classes and interfaces, and then we actually define the interface. So An interface in C# defines a contract that other classes must implement. So we're going to later create another class that has to implement the get all restaurants, get restaurants by ID, add restaurant, edit restaurant, and delete restaurant. And so we're going to use this right now by creating a new file. This is going to be the restaurant service. So we got pasted in this code. So we have imports, the namespace, and then we are going to implement the interface that we just created. And here we add this local restaurant reservation DB context object and a constructor that gets an instance of the DB context via dependency injection. Then we have the add restaurant method, which adds a new restaurant to the DB context and saves the changes. And also it's going to print the state of the changes tracker to the console. Now in production, you probably wouldn't use that. You would use a different method, but it's fine for this. And then we have the delete restaurants, obviously going to delete a restaurant. So you can see it's looking for the restaurant that has the ID that's put in, the first one that it finds, and then if it's not null, if it finds the restaurant, then it's going to move it or remove it, and it's going to save the changes here, or there's going to be an exception. And then edit restaurant is pretty much similar. We're going to pass in the new restaurant that's supposed to be updating. We're going to find the restaurant that's to be updated, and then we're going to put the new name, cuisine, and borough to the restaurant that we have to update. Then we're going to update it, and then we are going to detect changes, and then we're going to write those changes, and then save changes. Now we're going to get all restaurants. And by the way, we've been using the ID. The ID field in our document is a special MongoDB object ID type. It's auto-generated when a new document is created. What's useful about the ID property is that it can actually be used to order documents because of how it's generated under the hood. So we can order by descending, so it's going to start at the bottom, go up, or you can order by the top. The reason why I put order by descending is because one thing we're not going to implement in this is pagination. So that's something that you can implement later on your own if you want, but when we actually see the application, you'll see that it's going to list just so we have take 20. There's a bunch of restaurants in the database. We're only going to show 20 of them, and we're going to order by descending, so we're going to order basically display the last 20 documents added. And the reason why we're going to do that is so you can easily see any new documents that we added. So we could also just do, instead of order by descending, we could do order by, and it'll take the first 20. Or if you don't have take 20, it'll show all of them. But that takes a long time to load. Now, if you haven't seen it before, this as no tracking, that method is part of EF core and prevents EF tracking changes you make to an object. This is useful for reads when you know no changes are going to occur. Okay, so now we just have get restaurant by ID. That's pretty self-explanatory. We're going to get the first restaurant that has the ID that was passed in. Okay, I'm going to save this, and then I better save this file. So now that we're done with that, we're going to create the reservation service. So I am going to first make the interface, so a new file, reservation service.cs. And this is going to be pretty similar. So this is the interface that we have to implement. So let's do reservation service. And this is basically the same as before, but now we're doing it with the reservation. So we can add a reservation, and this time we just need to get the name from the restaurant that we're adding the reservation for, and we already have the ID that we're going to pull in. And we're going to delete the reservation, remove the reservation to delete, edit the reservation. It's all basically the same, but now we're just editing the date. That's really the only item that you can edit for the reservation. And For the reservations, we're also just going to display the 20 reservations, but we're going to order by the beginning instead of the end of the list of reservations. And then we can get the reservation by ID. So let me save those. We'll make sure to add them to the dependency injection. So let's go back to the program.cs file. Actually, let's close a lot of these files. Here's program.cs, and add 2 more lines where we're going to add the services, the restaurant service and the reservation service with the interfaces. Now we can create the view models. Before we implement the front end, we need to add the view models that will act as a messenger between our front and back ends where required. Even though our application is quite simple, implementing the view model is still good practice as it helps decouple the pieces of the app. So first we're going to create the restaurant list view model. This will be used as the model in our Razor page later on for listing the restaurants in our database. So first I'm going to create a new folder called view models, and then in here we'll create a new file called restaurant list view model.cs. Okay, we'll paste in some code here, and this is pretty simple because all this is doing is listing the restaurants. And these are all going to be pretty simple. So we're going to create a new view model, restaurant add view model. And again, I'll just paste in the code. Again, now it's just a single restaurant instead of all the restaurants. And then we have to do the same for the reservations. So reservation list view model. Again, this will be listing all the reservations. And then we have the reservation add view model, which is just showing a single reservation. Okay, make sure all these are saved. Now we have to add to the view imports. Later on, we'll be adding references to our models and view models and the views. In order for the application to know what they are, we need to add references to them in the underscore view imports.cs HTML file inside the views folder. So let me just show you where that folder is. Let's go to the views folder, and we have the underscore view imports.cs HTML. So there are already some references in there, you can see, but we're just gonna really only have to make sure we add one line. So we have the models, we just need to know that we have the view models. So I'll save that. Time to create the controllers. Now that we have the backend implementation and the view models we will refer to, we can start working toward the front end. We'll be creating 2 controllers, one for restaurant and one for reservation. So we'll start with the restaurant controller. So let's go to the controller folder here, and we're going to create a new file. This is just going to be called restaurant. And if you're using Visual Studio, you can use the MVC controller empty controller template. So we start by importing everything, such as the models, the services, the view models, and then we have the namespace, and now we have this class definition. Since it's inheriting from controller, this makes it an MVC controller. Then we're going to declare a private read-only field for the restaurant service. And now we have the constructor that takes an iRestaurant service and assigns it to the private field underscore restaurant service. This index action, this is an action method that retrieves all restaurants and returns them to the view using a restaurant list view model. And then we have the add actions. So this is a get action method that returns the add restaurant view. And this is a post action. This next section is a post action that adds a new restaurant if the model state is valid. Otherwise, it returns the view with the current model. So you can see it's just getting all the information to add the restaurant. Now we have the edit action here. This first one is just a get action method, just like before, that returns the edit restaurant view for a specific restaurant by its ID, or it will return a 404 not found. And then we have the post action, which is how you make the update. It's going to update will update a restaurant if the model state is valid, or if there's an exception, it will add an error to the model state and return the view with the new method. And similar with the delete, we have the get request that is just going to return a delete restaurant view for a specific restaurant ID, or we can do the get post request. And so for this post request here, it's going to delete. It will see if the ID we'll see if the ID exists, and then if so, we're going to try to delete the restaurant, and then we would redirect to the index page, or we would catch the error. And then if we haven't already redirected somewhere, we're going to view the selected restaurant. Now the reservation one is pretty similar. We won't go into it with as much detail, but we do need to make a reservation.cs file. And like I said, it's similar to the restaurant controller, but it has a reference to both the restaurant and the reservation service, as we need to associate the reservation with the restaurant. This is because at the moment, the EF core provider doesn't support relationships between entities, so we have to relate entities in a different way. It's going to be very similar to the restaurant controller, so I'm not going to go into detail. We'll just have the reservation service and the restaurant service because we have to get the restaurant information in addition to the reservation information. So everything else is very similar, including all the error messages. We're to the views section. Now that we have the backend and the controllers prepped with the endpoints for our restaurant reservation system, it's time to implement the views. So model, view, controller. We have the model controller, now it's the views. This will be using Razor Pages. You'll also see reference to classes from Bootstrap, as this is the CSS framework that comes with MVC applications out of the box. We'll be providing views for the CRUD operations for both listings and bookings. So first, we're going to create a listings view. Now, I'm going to open up here. I'm going to go to the views folder, and I'm going to create a subfolder called restaurant. And in here, we're going to provide a view that will map to the root of /restaurant, which will by convention look at the index method we implemented. ASP.NET Core MVC uses a convention pattern where you name the CSHTML file the name of the endpoint or method it uses, and it lives inside a folder named after its controller. So that's why we created the restaurant controller here. And inside the restaurant folder, we're going to create a new file called index.cshtml. Now, if you're using a template in Visual Studio, you can use the Razor View empty template. But here, I'm just going to add some code to the index file. So we're going to specify which list view we're going to use. And then right here, this is a placeholder for the error handling. If there was an issue deleting a restaurant, we added a string to temp data. So we want to add that into the view if there's data to display. And next, we are going to handle if there are no restaurants in the database by displaying a message to the user. And then the easiest way to display the list of restaurants and the relevant information is to use a table. So we're just creating a table that has these headings: name, cuisine, borough, actions, and you can see we're getting this. So for each restaurant in the restaurants that we get, we're going to list the name, the cuisine, the borough, and then we have these different buttons: the edit button, the delete button, and the reservation button. And then finally, we have a button to add a new restaurant. Now, it makes sense to have a list of restaurants as their home page. So before we move on, let's update the default route from home to /restaurant. So I'm going to go to the program.cs file. And then if I go down here, right now we're using the home controller, but I'm going to change this to restaurant. If we ran this now, the buttons would lead to 404s because we haven't implemented them yet. So let's do that. We're going to implement the buttons, the edit, the delete, and the add buttons. So to add a restaurant, do new file and add.cshtml. And I'm actually going to make that a little smaller here. And this is going to be pretty self-explanatory. The title, and then the error message. And then we are just going to create a form with different sections. So we have an input field for the name, for the cuisine, for the borough, and then a submit button. And then we just have a button to get back to the list. So that will go back to the list of restaurants. Now I need a view for editing. This is almost identical to add, but it uses the restaurant as a model, as it will use the restaurant it's passed to pre-populate the form for editing. So we have the model name here. So you can see it's very similar to the add one. So now we just want to make a delete. So a new file, delete.cshtml. Now instead of a form like the other one, this is just going to be listing the information. You can see the model name, the cuisine, the borough, and then it will do a form to delete a restaurant. And it'll say, are you sure you want to delete this restaurant? And then if you do, you click delete, and it will perform the delete action. So let's save that. And now we're going to add views for the reservations. So let me go to new folder and do reservation. And we're going to start with index. And this is very similar to before with the table. So I'm not going to explain it all, but we will now do an add.cshtml. And this is also similar. The only thing that's kind of to note is in the form, we're using a date time local type, which will allow a drop down for both the date and the time. And we're going to set the value to the current time and the current date and time. And then the person can change it to when they want to make the reservation. And when we specify the format with just hours and minutes, that means it's not going to have someone put in the seconds or milliseconds. We're just going to have someone put the hours in minutes. Okay, so now we'll do the edit one. And then the only thing to note in edit is that the title is saying we're editing the reservation for this restaurant name for this time. And you can see whenever we use the information for the date and time, so the date and time are both stored in the date field, and we always are going to put to local time. And here we're calling the to local time method. If we don't do that, the time will not display as expected. So finally we will add delete. And everything is pretty straightforward for this. We are going to put all the information, again using to local time for the time, and then we have the delete form at the bottom here. Okay, now we're basically done. I'm just going to add one more thing, which is optional to make it easier to navigate. I'm just going to add links in the nav bar to both our reservation page and our restaurant page. So what I'm going to go to the views folder and then shared, and then I'm going to open up the layout file .cshtml, and then I'll scroll down here, and I'm just going to update. This is what right now there's just going to be a home and a privacy button. I'm going to paste it, and so there's going to be a restaurants and reservations button, and it's going to use the restaurant controller, the reservation controller. So now we can actually just run this. So I'll go to terminal, new terminal, and then I can go into my directory and do .NET run. Now I just take this URL here. Okay, and here's our page. Now it says no results. I would expect there to already be results of the restaurants since we're connected to the database. So that means we're doing something wrong here. Let's see what it is. Okay, here's the problem. In our app settings, we have the database called restaurants, but if we go to the actual database on Atlas, we can see it's called sample_restaurants. So this is supposed to be sample restaurants. And then we also have to change this one. Okay, let me just run this again. Okay, now we can see all the restaurants. Now, some of the restaurants in the database don't have names. That's why you see the blank thing. And then we can see the cuisines are all other. In some ways, it would be cooler if we start the restaurants from the top instead of the bottom, which is actually pretty easy to change. We're going to go back to this. I just want to show you this really quick, which is in the restaurant service. And oh, that's reservation, restaurant service. If we do order by like that, and then I just restart this, and then you can see we have all these different cuisines, all these different boroughs, and all the names of the restaurants. But we're going to go back to how it was, because of wanting to be able to see our new restaurants that we add. So we can edit, delete, and reserve. Like, let's delete these ones that have no names. If they don't have names, why do we even have them in here? So delete this one. Okay, so let's add a new restaurant. Let's see if that works. If we scroll down to the bottom, add new restaurant, and we'll say Beau Pizza, and then cuisine pizza, and then so for this database, it's all New York. So basically, I guess that's not even a borough, but you can put anything. They're all New York boroughs. I don't think I mentioned that before. But now we have our own restaurant, including we can see all these other restaurants, and also I can do a reservation. So right now it's going to set the current time where I'm at, but I can set the reservation for the 29th, and we'll do 6 o'clock, and then I can reserve a table. Okay, now it's showing these are all our booked restaurants. So we have a restaurant booked at Beau Pizza for this time, and we can book another restaurant. So let's hear Indian Oven. We'll just do it for here. Okay, so now we have 2 booked restaurants. If we want to switch it, we can. So like maybe I want to change the date. So let's change this to the 30th, update reservation. So we've updated the reservation. And if we go to restaurants, we can also edit a restaurant. Like maybe I want to edit the name. So maybe instead of Indian Oven, we'll change this to Indian Stove. And cuisine, I'm guessing it's Indian. And then we can update the restaurant. And then we can continue to delete, reserve, see all the restaurants, the reservations. So it works. And if you want to make the application even better on your own, you can make it so when you change a restaurant name, it also changes the name of that restaurant and all the reservations. However, as it is now, when you create the reservation, it saves what the name was when you created the reservation. But we can go into the database and we can see how it is updated in the database. So let me go to sample restaurants, and I'll go to the restaurants here, and then I will search for name Indian Stove. And if I do the search, we should see right here. So the name has been updated in the database on MongoDB Atlas. Our application is complete. Now let's look at some advanced features of MongoDB Atlas. Since we already have access to the Mongo client when creating the DB context, this allows us to perform advanced MongoDB operations such as Atlas search and vector search. These features enhance your application's capabilities by enabling powerful search functionalities while still leveraging the familiar EF Core framework. Atlas Search is a full-text search engine provided by MongoDB Atlas. It allows you to run sophisticated search queries on your MongoDB data.
With Atlas Search, you can implement features like autocomplete, faceted search, and relevance-based sorting. To use Atlas Search with EF Core Provider, follow these steps. So you set up indexes in MongoDB Atlas, go to your MongoDB Atlas cluster, navigate to the Search tab, and create a new index on your collection. Then define the fields you want to make searchable. Next, define searchable fields in your models. In your C# models, ensure that the fields you want to search are properly defined. This is an example of the definition of a product model. Performing search queries. Use the MongoDB.NET driver's capabilities to perform text searches. Since EF Core itself does not directly support the MongoDB-specific search syntax, you'll need to use the driver in conjunction with EF Core. This is an example. This example shows how to perform a text search on the products collection. The text filter helps search across all indexed fields defined in your Atlas Search index. Vector search in MongoDB is used for searching documents based on vector similarities, which is particularly useful for applications involving machine learning, recommendations, and natural language processing. Vector search allows you to query documents using vectors representing text, images, or other high-dimensional data. While the MongoDB EF Core provider simplifies CRUD operations, some advanced features like Atlas Search and Vector Search require direct use of the MongoDB.NET driver. However, you can still integrate these operations within your EF Core-based application by using the driver for search functionalities and EF Core for other data management tasks. By combining EF Core and MongoDB's advanced features, you can build powerful and flexible applications that leverage the best of both worlds: structured data access patterns of EF Core and the powerful search capabilities of MongoDB Atlas. In this course, we've explored how to integrate MongoDB with Entity Framework Core. We covered the basic concepts and how to put everything together into a full project. By combining the strengths of both MongoDB and Entity Framework Core, you can build robust, scalable, and flexible applications, making the most of MongoDB's powerful features while leveraging the familiar EF Core framework. I hope this course has equipped you with the knowledge and tools to effectively use MongoDB with EF Core in your projects.